Okay, so for the register file, we're gonna have our data in, which is an 8-bit input, and we're also going to have a clock signal, which determines when we grab the data. And also we're gonna have VDD to power them on. And the output is also an 8-bit output. And when we combine four of these blocks together, we can get a 4 to 8-bit register. So we can get, for each one they have different clocks, and they all have the same data input, and they all have their respective 8-bit output from that. Um, the register is used in the 4 to 8-bit register as I showed here, which are made of flip flops. Each register is made of flip flops. These flip flops the value of the data for hold the value of the data for each bit. So one flip flop equals 1 bit. And like I mentioned before in the PC video, flip flops have three important metrics: um, TQ to clock, T setup, and T hold. And in order for the circuit to work properly, we need to have a decoder and some combinational logic to help determine which register we are writing to, as shown in the top module here. So the here we're determining the clock, or from here where we're getting this decoder, and we bring in see if we need to write first, and we need to look at the clock and then send it back into the register so that we can write at the certain register we want. And similar to testing a flip flop, I would use um, in my case, let's see, here's me testing the flip flop. I would use like a pulse chain of mismatched pulses such that data or different data is being saved at every clock, and check to see if the data being outputted is the correct value that we expect. For example, this is how I tested a singular flip flop. You can ignore this part. This was testing the inverters, but yeah, this is how I would test them.